Okay. Yeah, so I'm just going to give a talk which is kind of like an overview of where we are with WebAssembly since ever we released it, right? Quite a bit has happened, so I can talk a little bit about the process of that as well. And then really just have an overview of all the kind of new features that are in WebAssembly and are going to be there in the future. And nothing here will be particularly deep. I'm aware that some of you probably already know most of that stuff anyway. And yeah, I'm not sure I will get through all the slides. We'll see about that. So the previous times I used that, I ran out of time a little bit, but now we are talking about garbage collection tomorrow anyway, so I can skip that almost entirely. And Sam will talk about the continuations or effect handlers proposal tomorrow as well, so I can also skip over that. So there's some chance there. I'm mostly assuming that you're already familiar with WebAssembly and some of the technicalities. So this is not really an introduction to Wasm at all, right? This is really targeted at people who know Wasm, want to see what's essentially. Okay, so WebAssembly 2.0. That's the slide here.
So different point at the speaker.
Probably, yeah. Oh, that's much better.
Well, I'm not sure what's happening. When I advance slides on my machine, it works. Not
Try resharing your I'll share. Try to do things with multiple computers.
I've got bad internet connection, so I'm not going to be able to field chat. Conrad, can you do it? But anyway, it's Ben and Ben.
Where's even the Peter did something. Now I have no idea what he did. I don't have the main window anymore for the thing. So I don't have a share button. Oh, here it is.
You can see it.
Yeah, but you can't see when I advance this one.
When you share the screen, you have two options to either share the window or the
Yeah, I share the window.
try sharing the other kind of things. So.
Okay, sorry about that. Technology. Right, so first of all, this slide again, just as a reminder, I'm not going to go through all of that, like all the roles and constraints, design constraints we have for WebAssembly. And with respect to this audience, I guess these are the most interesting ones, right? Which cater to formalization, reasoning, and all that. And so, but that were kind of like the official goals, but then we also had this whole set of secondary goals, which are to some extent less publicly known. So the first one is obvious, we want it to be an open standard, right? Keep it that way. So all the discussion is public. Everybody can participate, everybody can vote actually. We want the design to be universal for WebAssembly. That was quite important to us as well. So it's not actually a web-specific technology at all. The core spec doesn't mention the web, I think, or maybe exactly once in some note. Likewise with JavaScript, there's nothing specific to JavaScript in there. And yeah, I guess that's what everybody says who kind of designs the technology. They want it to be principled, right? We want it to be principled. And in our case, that means actually apply lessons from programming language research, but also from industry, right? Like there are lots of lessons learned from VM design, practical VM design as well, which we incorporate. But in particular, I mean, my contribution was more like on the formal side, and they wanted to apply all the things that have been developed in the last, I guess, 4 decades of research programming. And the goal here being really like raising the bar of how people talk about programming languages, how we specify programming languages, because the practice, the state of the art for real world languages is still like extremely like retro, right? It's basically the same as people did in the 60s. So like if you look at an official language specification of some industry language like Java or let alone C++, it's all just prose and wishful thinking. So really we wanted to make a leap of, I don't know, maybe at least 2 decades or 3, I believe. And by that demonstrate that all these techniques actually work, right? They're ready for prime time. They work for an industrial strength technology. And I mean, to be fair, WebAssembly, at least in its initial version, is relatively simple when you think about the formal semantics. When you think about the formal semantics, so we probably had it easier than like a full-blown user-facing language would have it, but still, I think we demonstrate that this actually works. And yeah, and also like Ben and Luke, I think we're interested in doing that also to provide a solid foundation for research, right? For researchers like you guys. So people can just pick it up. They don't have to academia don't have to invest like several PhD careers or something in reverse engineering what we probably meant when we wrote the spec and then formalize it after the fact. We wanted to do it right away and have a feedback loop for design. And that, like advanced, I already said that, right? Advanced state, and I would claim that doing this whole formalization as part of the design process also led to significantly cleaner and simpler design, because you see what is actually makes sense and what doesn't if you have to write it down in some concise way. So here's a little list of because you are interested in formal techniques. So this is kind of a version of a talk I gave some weeks ago at the Program Analysis for WebAssembly workshop. So, and I wanted to get some feedback on what are the difficulties of dealing with WebAssembly for program analysis and what are the things that makes it maybe easier than other techniques. So I tried to compile a little list of the things or the properties I think make it easy and make it hard. So this is what I think is beneficial if you want to do formal things. Well, first of all, it's type. That should be kind of no-brainer, at least in this room. Then somewhat more like technical, there, like in the instruction set, there's no overload, right? So if you have something like the addition instruction, it exists separately for every type. So you don't have to infer it from the operand stack or something like that. And the program analysis folk mentioned that explicitly as being something that's actually simple. Then there's this somewhat more controversial thing, which is that control flow is structured in WebAssembly, right? You know about that. There are no arbitrary jumps. You just have blocks and breaks, essentially, continuous. So that also, of course, makes things easier. A big thing, really, although not even visible because you don't even think about it most of the time, is there is no call stack. Right? It's not exposed. We have function as an abstraction. You have call instruction. And that's it. It's more like in a programming language in that regard, and not like real hardware. Right? Remember that WebAssembly is trying to abstract real hardware as low level as possible, but in this particular case, we're abstracting away from hardware. And of course, the reason is to get certain safety guarantees for food. Somewhat related to that is also that WebAssembly, despite being kind of an abstract CPU, is not actually a von Neumann architecture, it's a Harvard architecture, meaning that the code lives completely separate from the data space, right? There are also no code pointers or anything like that. So various attack vectors that you have on real hardware simply don't exist because it's completely separate. Then there's the whole thing with the module system, so which is pretty strong. You really have imports and exports only, and that's the only way for a module to interact with its environment in both ways, right? So the module's internals are completely encapsulated. But also the module cannot access anything from the outside without it being given, right, explicitly by the person who instantiates. So there's full control. It's basically kind of like a capability system. And there are no ambient capabilities in WebAssembly. So if you run code, you can heat up your CPU, and that's all you can do without anybody providing you some. Yeah, big thing, of course, consequence of doing proper formal work here is that we actually have a fully specified semantics. So there's zero on the, like very unlike all other low-level languages you've ever used. Right? So I think this is really, I mean, it's important for the use case of WebAssembly because it runs on multiple hardwares. You don't know where you're running on, so you also want portability and things like that. It's already important for that reason, but of course, I guess I don't have to convince you preaching to the choir here that this is a good thing to have. And as part of that also, it's not just defined, it's also almost entirely deterministic, at least in the original version, the release version of WebAssembly, but you might be aware that there's this tiny rule which has to do with floating point numbers, which is the bit patterns chosen for NANDs, right? So there's this unfortunate fact that the IEEE standard doesn't specify that, what the bit pattern of a NAND is when it gets generated, and CPUs actually differ. They disagree, and they disagree in really weird ways. So one of the NAND things is actually a signaling bit, which isn't particularly well defined what that means, but interestingly, CPUs use it in inverted ways. Like one uses 1 for signaling and another CPU uses 0 for signaling. So it's like completely. So we underspecify that basically in the form of a very mild.
Excuse me, can I ask something?
Yeah.
So I haven't done any sort of thought about compiling into Wasm. So on your undefined behavior comment, I'm going, what happens with C and define?
Well, you just have to map it onto some defined behavior, right? But basically the nature of undefined behavior in C is you can compile
you
it.
have
what,
to make some choices.
Yeah, but you can compile it whatever way you want because it doesn't matter, right?
It's the easy direction.
Yeah, it's the easy direction.
No.
The hard direction is actually edge cases in the floating point stuff. The source language has more guarantees about the bit patterns.
Right. So one thing, for example, with Definity, where I used to work, we run WebAssembly code in a replicated fashion, so we really depend on full determinism, right? So even this tiny bit for floating points, we can't afford that. So we have to do some extra work to normalize all of this, so they are really the same all the runs. But I think what you mentioned is when you compile languages, I don't know what would be an example right now.
Rust actually is trying to have deterministic semantics in their floating point bit patterns.
Good luck with that. We started out with the deterministic semantics, and then we discovered increasingly all the problems we ran into, and then we like incrementally relaxed it just as much as we needed to for this going through. Anyway, and as you know, it's fully formalized and mechanized, so thanks to you all guys here, we have that too. Okay, but there are also some design factors which are probably harder to deal with than maybe some other languages. And that is, of course, like I mentioned types as a plus, but they're also extremely boring. So you don't really get off that much, right? So in particular, you just have numbers. Numbers are used for pointers. So if you have a number, you don't really need that, whether it's a pointer or anything else. And if so, what is it? I mentioned that already. And then the big thing, of course, is that this is really a low-level language. So the memory model is extremely low level. And here's where you're really dealing with the likes of machine. Right? So all your memory is just raw arrays of bytes. And if you want to do program analysis or verification kind of things, you really have to start inferring how it is used, what that means, and those things. So the language doesn't give you any help. So,
There was a comment in the chat.
Oh.
Stuff.
No, I wasn't.
Read that out.
There was, do you really want me to read it out?
I can read that in future, I just will join the call here.
Okay. Recent discussion on man in Isabel mailinglist. This is from Bevenger. Also touching on how clock treats this. Appel's recent work in BST implies that verified programs are NAND free. So the representation of non-determinism doesn't matter.
Okay. Well, that's good to hear.
What was that?
It was just a joining session.
Yeah.
Okay, yeah, thanks for that comment. It might still matter in some circumstances, but I agree that for most programs, like realistic programs you want to reason about, it shouldn't matter because you can't observe it in most programming languages in the first place. But it matters if you want to do certain techniques like, I don't know. So another thing is I mentioned that the call stack is like not exposed, but when you want to compile languages that actually do nasty things with the stack, like C being the first example where you can take the address of the stack local. So what do? You can't really map that to WebAssembly directly. So what you have to do is you have to maintain a shadow stack in the linear memory for all the things that have their address taken. And then you back into the linear memory thing and all the problems you have also with the possibility of corrupting your stack, at least to some extent. I mean, this shadow stack will still not have return addresses or something like that. Can't mess with those, but you can still have maybe array overflows and whatever created garbage there. Yeah, then also a consequence of this memory model is, well, we have the nice modularity feature, but ultimately, since this one huge byte array is the only thing you can store and transfer data, and you really have to have multiple modules share that thing, and you can't really protect private parts of it if you want to. That just doesn't right now. Yeah, and there's a whole thing with the module system where you have to start reasoning about modular programs. So many of these program analysis techniques, so that's maybe why I have that comment in there, are kind of assuming a whole program scenario, and that is not true by design for WebAssembly. So if you really want to do program analysis in a proper way for WebAssembly, you actually have to be able to. And I'd be happy to discuss these lists more. There might well be that I forgot some things. This is kind of like all I could think of, but I don't know if you guys had encountered things that I forgot to mention. I'd be very interested. Okay.
Can I go back to that sharing memory?
Yeah.
Between modules. So at the moment, you're doing very strong encapsulation properties between different memory of different modules.
Mm-hmm.
So what are you going to do are you wanting to ensure that same sort of encapsulation, but with the sharing of between them?
So basically, currently you have a choice, right? But you only really have two choices. So a module can either have its memory private, or it has to either import or export.
So there's import exports, and then it's those functions that are hitting at the memory of the particular module.
If you want, so you either completely share the memory between the two modules, and then you have no protections at all. They can just crap all over each other's things inside the memory. Or you keep the memory entirely unexported, but you can then export functions from the module that provide an interface for forcing the module to do something.
Right, but
that's saying completely sharing.
So in practice, right now, in practice you have to share it because like abstracting it and then exporting functions will be very expensive, right? Every byte access will be a function call, and you have no way of transferring bulk memory when you need that. You really can't copy between the memories of multiple modules either, right? If you want every module to have its own memory, how do you even transfer anything that more than a number, right? It doesn't. That's not possible. So in practical terms, you have to share them.
So then it's about, we're just not thinking about encapsulation.
Right. There in practice,
we haven't got an interim place. That's the bit.
And there's a very sensible question in the chat. Concurrency, is the memory model C11 slot? And I'm unhappy to report that yes, it is exactly C11
That's where I was asking.
So, right. I mean, currently there is no concurrency, right? So currently this problem doesn't even exist, but part of the work that Conrad has been doing with me was defining the memory model for the thread edition, and that's one of the things I'm going to briefly hit on.
We are at least a little better in the sense that there's no arbitrary undefined behavior on data races. That the semantics we've chosen instead is also not completely formally kosher. It's just slightly better. What we really need is a solution to the thin air problem before we get the right one.
Yeah. Okay, any more questions? Okay. Right. So just also a reminder of the kind of general roadmap that we have for WebAssembly. So the first version we released was really targeting low-level languages, right? Because they were like C++ in particular was our first immediate customer. There were already people who compiled C++ to the web via ASM.js or NACL. And basically the goal of putting WebAssembly out as quickly as possible was to make these technologies obsolete as quickly as we can. Because both the teams that worked on these were working on WebAssembly really wanted to get rid of that kind of so we deliberately focused on low-level language support for the first generation of webs. And most of what we have been working on since then is kind of like adding better support for high-level languages, whatever that means. I'm going to mention a couple of things there. And then you could think, I mean, there's this vague idea that somewhere in the future, maybe we also want to support dynamic languages for some suitable definition of dynamic. I don't think there's wide agreement what that means. But this is still very, very, I'm not aware of anybody working concretely on any of this. I mean, we have hardly enough time with the second thing right now to worry about that too much. But some things keep popping up. So like, eventually, we might want support for some kind of JIT compilation. Okay, so talks titled WebAssembly 2.0. Why do we have 2.0 now? So I should briefly talk about the whole release process we have. So we have recently switched to what is called the evergreen model. So WebAssembly is released under the W3C, and that has recently introduced this notion of an evergreen release model, where basically you just have a live spec document. You just keep updating. And whatever that document says at any point in time is the current standard. So this is like what's called evergreen. So we already operated in that fashion before. Since we released the first version, we have already updated the document, but kind of technically speaking, from the W3C perspective, that the official standard wasn't updated yet. So now we officially switched to this model, and for some bureaucratic reasons having to do with how W3C versions its standards, we had to bump the version up for that, right? I said all that. Exactly. So we already had like WebAssembly 1.1 essentially, which we were iterating on, but now we basically were just rebranding to 2.0. So all the features that previously were in 1.1 are now in 2. But from now on, the idea is that because we got complaints about the lack of proper version numbers with the standard, we just kept merging in stuff and didn't bump any number. We now want to do that. So the idea is that from now on, we just want to bump the minor version every time we merge a major feature or any proposal actually. So 2.1, 2.2 from now on, whenever something interesting actually happens. So people can talk about which version they are implementing, which version they are requiring, which before was just, yeah, I need WebAssembly plus this feature set, which is not very practical. So what is WebAssembly 2.0 then, or 1.1 previously? You should think of it now as the current version of WebAssembly. That's really what WebAssembly is. And yeah, was just rebranded. And if you want to see an overview of the things that have changed, there's like a very high level changelog now in the appendix of the spec. But I'm going to walk you through some of the things. But before I do that, another piece of thing I want to talk about is what's actually the process for changing the spec, right? Because that's interesting as well. Right. So we have a pretty elaborate process. It is open, so anybody can participate. Anybody can make a proposal. There are no prerequisites for doing that, but you have to basically commit to becoming a champion for that proposal. Right? So every proposal has to be driven by a person or a group of persons who are the champions, who are doing the work of pushing it forward. And you have to push it through multiple phases. And the last phase is phase 5, which means it has been merged into the standard. So that's when it's actually standard. But for every phase, there has to be a vote by the WebAssembly community group, which is kind of like the working group, if you want. I'm not going to go into the administrative detail of the difference here, but it's like the group doing all the discussions. And there has to be a vote for every advancement, basically. And also, as an aside, when you propose something, there's a very, very strict backwards compatibility. You really can't change the behavior of pre-existing valid programs, right? You can make invalid programs valid. That's what you can do and have to do, obviously, but you cannot change the behavior. So what are these phases? Every phase essentially has a number of deliverables you have to come up with before you can proceed. So for phase 1, it's really just you have to basically give a presentation at one of the meetings and sketch the idea and motivate it. And then the working group can decide whether they want they think it's reasonable to invest into this. Then you are in phase 1. So that's a very low barrier. You don't really have to. You just have to prove that it's not a completely crackpot idea, right? Then phase 2, already you have to do some work, right? So for phase 2, you really have to come up with a fairly precise description of the extension in terms of what that adds to the language. So you have to describe it with enough detail that somebody could go and implement from that. But it doesn't have to be formal yet. It doesn't have to be real spec text yet, but it has to be precise. And then for phase 3, to enter that, you have to have a prototype. And prototype can really be anything. It could be in the reference interpreter that we have, but you could also prototype it in an engine or like do your own thing entirely. But you have to provide something that's executable and where you can run a test suite against, and that you also have to. So the WebAssembly standard, the repository on GitHub, contains a huge test suite for all the features, and you basically have to provide the extension to that test suite as well. With enough coverage, right? There's no particularly well-defined criterion for that, but right. So that is where most of the interesting design work happens, like for phase 3. Right? And then phase 4 is kind of like finalizing the technical requirements. So now you really have to do extend the reference implementation in OCaml, which has to be able to run the test suite. And you have to write the actual spec text, and you have to do the formal work. You have to do the formalization. So that is the strict requirement. There has to be an extension to formalization, and as a champion, you have to provide it. Or you have to find a person who can do that work for you, right? Which is more often the case, unless it's a feature that is fairly easy to specify in terms of some common things. So yeah, that's really a strict requirement. And then in practice, the hardest barrier though is the last one, which is it cannot be merged before there have been 2 implementations in real production engines, kind of as a proof of validity of this feature. So it can be implemented efficiently and can support it probably in tool chains as well. So where applicable, there also has to be at least one tool chain that can generate this feature, right? So that we have both consumers of the features and producers of the feature. So, and only if that all works out in practice and people are sufficiently confident that this is reasonable, only then, when all this happens, the feature can get standardized. And
can I ask about that? So What's the definition of a production engine?
That's a very good question. So historically, that has meant one of the major web engines, which is increasingly inadequate, if you ask me, because the number of those has shrunk.
It's not, and your purpose is more anyway.
Right, and so there have been discussions before on how to change or relax the definition. So there are now non-web engines like Wasm 2.0, for example, which you could regard as production because they are used in production. But last time we discussed this, which was 1 or 2 years ago, I think there wasn't consensus to do that yet, because the web people, they really want to protect their turf, they want to keep control of things, right? That's why they don't agree with that. But I think eventually we will. So basically, the idea was maybe say 2 production engines. One has to be a web.
And the real issue here is there aren't enough web engines anymore.
Yeah, right. So there exactly. So
right, there's
there are 3, right? Google, Mozilla, and Apple. And Apple usually doesn't care, so they're useless for this. So basically, we're always Google is usually furthest ahead. They implement everything, but then we have to wait for Mozilla to actually have resources to do it. And that's where most of the proposals are stuck for the longest. One example being tail calls, which has been in the state where we have 1 production engine, and I think it has been in the state for 4 years. Everything else is there. We're just waiting for the second engine. Apple is now implementing it, seems, but has taken a long time.
And what does implementation mean in the sense that does it have to pass most all tests? How
it has to pass.
It have to relate to the.
It has to pass the entire test.
The entire.
Yeah. It has really to be a complete implementation.
It then makes the point that Igalia is helping implement teleports in Safari.
Maybe, yeah, I don't know who exactly is doing the implementation, but yes. Right. Okay, only 20 minutes left. So.
Oh, sorry.
No worries. So I'm gonna go quickly through
Just go on.
Yeah.
The discussion. Just go on.
Okay, fine. The most trivial extension is probably multiple values, and it's trivial in the sense that actually our original paper already included it because it's so natural. So I just gonna skip over that. That wasn't actually part of the first release of WebAssembly. Okay. Then the most interesting one, and that is related also to what I'm going to talk about later with garbage collection, is the addition of reference. So for now, it's a very simple version of reference types. So really, there are now 2 new value types. So just to recall, WebAssembly so far only has number types, right? Ints and floats. That's all it has. That are all the values you have. Now we're adding 2 new types, which are called funcref and externref, which are the representation of a reference to a WebAssembly function, like opacally, or some reference to something external from the host. So for example, on the web, this could be a JavaScript. And then you also have null, so you have instructions to produce these references or check for null. So for example, you can have, this is basically the address of function operator. If you want, you reference one of the functions in your program, you create a null reference and you check. Those are the 3 primitive instructions. And the important thing here is references are opaque, right? And that is absolutely crucial for, obviously, safety and security. There's no way for you to observe their bit patterns at all, right? That would be completely unsafe because they could be host addresses, for example, or code addresses. And that also means you cannot store them in memory, because then they would become observed. So what's the motivation here? Well, mainly at this point of the proposal, we care about externref, and that gives you a way to take host addresses like JavaScript stuff and round trip them through WebAssembly, store them in reference to WebAssembly somewhere. For example, if you want to deal with DOM objects, right now previously you couldn't do that. You somehow had to map them to numbers. You needed to have this bijection that you have to maintain on the way in and out. You have to garbage collect yourself. It's all pretty cumbersome and fragile. So now you can just take a reference that use it as if it was. But it's also the foundation for multiple of the other things. So here's a very stupid example. So for example, you can now have a module that stores the current window object, right? So you would just have a global variable of type external if it's mutable. You initialize it with null, and then you can export a function that allows the client to set that variable to something. You also have a getter. So a very stupid example, but just to show you at least a tiny piece of code that's using. So the overall picture of the kind of type hierarchy in WebAssembly is now a bit more interesting. So previously you had value types, that was the types that values can have, right? And that was really only numeric types. And you had these 4 previously. We now also have another one, which I'm gonna talk about in a minute. But yeah, all these types are transparent. You can observe their bit patterns and you can store them in. And now we have this whole other thing, which are reference types. They're entirely opaque. We currently have these 2, and you cannot store them in memory, but you can store them in tables.
So we do have a question in the chat.
Yeah.
Can you expand on the rationale for including null references, given that Paul called it his multi-billion-dollar mistake?
So the rationale for now is that they technically were already there in the sense that tables have them. So let me go to the next slide because that is going to explain that. First of all, some implications. Yeah, sorry. Can you hold on the question for a minute? I don't think get back to that. So, of course, this has some implications, right? We now have first-class function reference, so really high-order values, and that means we also have a high-order store. So, kind of the semantics is going interesting. And another more practical problem is that reference, at least as of now, are not particularly well supported in tool chains, especially in LLVM. So, kind of Rust's holding us back a little bit here because they have no clue how to really deal or model them in the source line. But yeah, I mean, there are some opportunities here if you want to do formal reasonings. Of course, opaqueness gives you an abstract value with very few observations, so you can reason about it in a much more abstract way than if you had a concrete number. So I said you can store them, you can't store them in memory, you have to store them in tables. So one idea here is, well, I mean, yeah, you can store them in globals, but that might not be flexible, right? If you have a dynamic number of them. So the idea is that we repurpose tables that we already had. So previously they could only store functions. Now they can store any sort of reference. And we also extend them with the same kind of things you can do on memories, which is like rowing them and accessing them within WebAssembly. So you can read, write, and grow tables now. So you have a bunch of new instructions for that. And they can have arbitrary reference now as their element type. And as a consequence of that, we also finally allow multiple tables being in a single model so that you can have tables of different types. It's kind of a consequence of having different table types. You also want multiple tables in general. So this kind of closes a gap here. Let me move on a little bit faster here and show an example. So this is a bit of a generalization of what I showed you before. So that would be a model that now has 2 tables, right? One is, I don't know, storing some functions for whatever reason. The other is storing a growing number of window objects or JavaScript objects now. And you have a counter which just keeps track of how many you already have in there. And then you could have a function that registers the new window. And the code is just the usual thing you do. So you first check whether there's still space in your array. So this is essentially like an array of references, right? So whether the size is large enough. If not, you grow it. And after that, you just stuff the object. So really nothing magic, just to see how you use that. And this is where the null also comes in, because we had tables before, right? And table entries could be defined or not. So essentially, we already had null entries in the table. And for practical reasons, as you also saw on the previous example with the previous slide with the global, you need kind of some value with which you sometimes can initialize these things if you don't have anything concrete. But I'm going to get back to that later. There will be something better in the future. Another thing that has been added in WebAssembly 2.0 is just like bulk instructions for covering memory ranges and table ranges. Not very interesting semantically, but it's really just gives engines a way to produce more efficient certain operations. And then the last thing, which is probably in terms of sheer size by far the biggest, is WebAssembly now has vector instructions. So SIMD, right? So this is the V128 type that was on the previous slide. So that's a type of that is 128 bits wide and is interpreted as a vector of values, of numeric values. And it's also a transparent type, really. But yeah, there are now various so-called SIMD. So SIMD means single instruction, multiple data, so vector instructions, right? That can manipulate values as vectors. And the shape of that vector is kind of interpreted by the instructions. So similar with numbers where whether something is signed or unsigned is the interpretation is up to the instruction that interprets it. Here, the shape with which we interpret such a value is up to the instruction. So for example, for addition, we have like a whole range of things which interprets it with different sized integers with different numbers of lanes of same fields. So there's a whole range and family of these things. And then there are also various ad hoc instructions for very special operations. And of course, the use cases here, I mean, this is what modern hardware has. And for some niche use cases where you can parallelize and vectorize, like codecs and encryption stuff and other like parallelizable computations, this can be quite a, it can, in cases like W performance on certain things, maybe even more if you're really lucky. The main downside is it's really huge, right? So we're talking about 250 new instructions here. They're pretty complicated and ad hoc. So if you want to formalize this in Coq, you're going to have a fun time just doing all the busy work. Not pleasant. So when I moved this proposal, and when I landed this proposal in the spec, the pull request for that on GitHub, containing the spec, the reference interpreter, and the test suite, I had more than 100,000. I mean, 3/4 of that are tests, which are mostly generated, or many of them are generated, but still it's like 25,000 lines for the other stuff. So there's a lot of stuff here. It's really, but yeah, that's what people want. And of course, GitHub UI completely broke down. That's the problem. So that is what is in WebAssembly 2.0. Okay, that is the current stem. Questions about that? Are you already horrified?
We have a question from Peter Sewell in the chat. Can this vector instruction stuff just be uniformly generated from ISA model? And I think this gets to having to abstract over the different architectures, SIMD.
Right. So one of the design considerations for WebAssembly always is like, when do we add some instruction? The requirement essentially is it has to be mappable, at least with all these low-level instructions, mappable to existing machine instructions in a direct way, right? Ideally one-to-one, which means, and across all the relevant modern CPUs, essentially. So essentially, this means that we are in the intersection of what these modern CPUs provide. So we only provide what is in the intersection of all the existing. And there are sometimes minor differences between them. And in some of these cases, we have decided, like at least for now, we have decided to still maintain deterministic semantics. So for some hardware, you might have to make it a little bit more expensive, but we have deliberately left out instructions where you can't really do that without losing all the benefits. But that means also that their semantics should be somewhat like fairly common and standard, so you should be able to generate.
Yes, so in particular for SIMD, there was a whole kind of side working group set up to work out which instructions could be safely added to WebAssembly in such a way that all the modern hardware can support in a deterministic uniform way.
Yeah.
And that took a lot of work. So it wouldn't be as simple as taking any one ISA model and exposing that at the WebAssembly level, you'd have to calculate what's the kind of safe deterministic intersection of all the ISA models we want to calculate.
Okay. So are the ISA models just ARM index 86, or are there more you care about?
I think some people also cared about what's the, this is awful, what's the open source one? RISC-V, yeah. Some people also cared about RISC-V. I think that's the main one.
But yeah, in practice, it's mostly up until ARM.
Peter has some.
Peter has a follow-up. Yes, but having defined that intersection then, are you saying that you've designed it, or are you saying once you've done the work to design it, everything is fine?
Let's see if this audio works.
Hello.
Yeah, works.
Yes, I can hear you.
So it's clear that someone, i.e., you, not me, for sure, would have to think about the extension and what's expressible in x86 and ARM and whatever. But having designed that intersection, then perhaps one might just take the one of those architectures' representations of all the instructions and all their semantics.
So this is about automatically generating the numeric semantics part of the Wasm spec from some architecture level spec.
Yeah.
Yeah, I guess the main problem there is to bridge the gap of the formalism or whatever, right? I mean, this work has been done, so one guy from Google has basically written down all the formal semantics of these new operations. But I have no idea how they map to other formal models of ISAs, to be honest.
I think Peter's interest in this is presumably that he actually has a formal model of the architecture level. And it might be interesting to see how, given that we have the WebAssembly level model and the ISA level model, it might be interesting to see, starting from one, how automatically you get to the other.
Yeah. But I mean, this is part of the broader question of like, how much can we, I don't know, automate, if you want, some of the spec work. And so far, we don't have any good story for that at all. Practical terms, it's pretty difficult, I think.
So in particular, so this is just going to the formalism of 250 instructions. That presumably somebody went a bit mad doing that. I mean, in reference interpreters, sure, but then did they also do it by hand?
Yeah. Whole thing.
I mean, you can reuse a lot of stuff, right? It's often just some of the existing meta operations for ins and floats mapped over a vector of things. So lots of the kind of numeric meta definitions we already had could just reuse, but it's still just like stupid labor.
There's something not satisfactory.
Yeah, of course. I mean, there's nothing elegant about this at all, even from the whole design point already. It's super ad hoc instructions. And that's just because the CPUs are so ad hoc with respect to this. Like there are just some completely random instructions in there that just work for one particular shape. You don't know why only this shape, or there are others which work for all but one shape, and why? Okay, because that's just the reality of things. So there's no regularity.
And you scrape the formal semantics from
Not the kind of reference interpreter we have now, but I guess if you wrote a more principled kind of reference interpreter.
I mean, the idea is that the reference interpreter is kind of the OCaml rendering of the formal semantics, right? That's how I wrote it.
Yeah.
So you can just hand translate that OCaml code most of the time into, I don't know, paper code if you want to.
It might be more realistic to generate the OCaml code from a very structured definition.
Yeah, so
it sounds as that paper definitions
Yeah.
not great.
I mean, that's probably even harder, right?
Mechanization.
Generating something from LaTeX, I don't know.
Yeah.
Yeah. Anyway, good thing for discussion. I'm pretty sure this is the most horrifying part for you.
Yes.
Okay, so where are we going from here? There are many proposals. I don't think I'll have time to go through all of them. So I'm going to skip over some of them because they're relatively simple. One important one is extensions to the memory model, right? So there are actually two. One is extending to a 64-bit address range. So basically, you can now have loads and stores with I64. And the other is allowing what we talked before, actually allowing multiple memories within a single module, either being defined or imported or something. That would allow a module to actually selectively share some of its memory. So it's really, like with multiple table, this is really a thing we anticipated in the WebAssembly design from the very beginning, but just left out initially because it has some additional implementation. So now we're kind of finally closing all these gaps. Yeah, so, and the use case for that should be fairly obvious, I think. What it does, though, technically, if you have multiple memories, you have some kind of like segmented memory model. Right now, you have a pointer like an integer, but you need to know if you want to do reasoning, what memory, which memory it actually refers to, right? That's not apparent from the type. It's not really segmented in the sense that they are completely disjoint, right? They're not overlapping like crazy old Intel models, but you still have addresses that are semantics is relevant to some ambient knowledge. So I don't know how that affects actually.
What's the argument for having just the single line memory at the start?
So primarily that's easier to implement efficiently. So you would just reserve one register for the base address of the memory, and then you just can have all the memory operations as set relative to that, right? If you have multiple ones, there's no upper bound on the numbers, so you have to use an extra indirection. Then either more work or less efficient.
And also not just what Wasm.js is.
Yeah. I mean, for C, right, you just have this one linear address space. So here's a simple code example, like, yeah, two memories now, and this additional thing here now is declaring the index type. So this would be plain old I13.2 memories. And previously that was just implicit. Now you can actually write it down. And then you can have like loads from one memory and store to another memory. So fairly obvious. So you can have a memory copy. Right? Nothing as you would expect. There's nothing surprising. Or this is how you would define memory with I64 address space. You would just say that next is I64, and then you can store something at a big address if it's large enough. So then tail calls, very quick because it's really nothing much to talk about. Obviously, we want that, right? Anybody disagrees in this room?
What about debugging?
Yeah, right. But the way we do it is not by depending on some like optimization in the engine, but making it explicit. So we have explicit instructions that are the combination of call and return. Essentially. So return call is a tail call. And then for all the other call instructions. And as I said, the proposal has been ready for years. It's finally getting implemented. So hopefully soon. I mentioned before that references, we are going to improve on those. Most of this I will talk about tomorrow. So just like a brief teaser, we're going to extend the type system for reference to actually be typed properly. So not just some generic function reference, but actually what type of function will be reflected in the reference. And it will also be reflected whether it can contain null. So we will have two new reference types of this form, either a non-nullable reference to type T, which could be a function type, or a nullable. Okay, but I'll talk about that tomorrow. Similarly, with garbage collection, I will talk about that. There's the exception proposal where the goal was to, this was the main missing bit, or one of the two missing bits to support C++ compilation. Right now, the way you compile C++ with exceptions turned on to WebAssembly is for every try catch, you call out to JavaScript, create a try handler there, call back into WebAssembly, and it's like, yeah, obviously it's not feature complete. Also turns out that almost nobody cares because nobody's using exceptions in C++ because they're pretty bad in C++, but there was at least some pressure to do something for it. And the model is kind of, it used to be kind of very straightforward, almost like ML exceptions. It now turned a bit into a Baroque whatever contortion. But basic idea is still you have new declaration form for exception tags. So really like an exception declaration in ML. You have a throw instruction that would just throw such a thing. And you have try catch, which is like this huge monolithic kind of thing, like really in Java or something, where you can have multiple catch clauses. So previously we had a design where there's just one catch thing, and then you have factored out the dispatch on that thing into a separate instruction. But for reasons, whatever. So for reasons, we now also have a rethrow, which is somewhat contextual, restricted instruction that can only return, only appear in the catch handler, and rethrows the exception from that handler. So kind of like the rethrow in C++. So previously we didn't need that because the exception packages were actually first-class values, so all that went away. And also we have another kind of try catch, which is catch it here, but handle it somewhere else. Which is also a consequence of not having this thing first class. And this is needed to compile SSA-based, control flow graph-based representations like LLVM to WebAssembly, because, yeah, if you need to compile exception edges, then you need some mechanism like that. You can't encode that. But that's the general idea. I guess what this means is relatively intuitive, but it's not. And yeah, there are various challenges here in practical terms, like exception models really differ across languages. Reason for this Baroque design is existing factors. Then there's another thing, which is continuations. Again, I'm not going to talk about that because that's what Sam is going to talk about tomorrow, I think. So this is a collaboration with Sam Lindley and Nathaniel and a whole bunch of other people. Adding some form of effect handlers to WebAssembly, basically to get a typed version of delimited continuations so that you are finally able to compile all these control abstractions. Right now, you can't do that. There's no way you can do that. So that's obviously missing.
Is it definitely delimited continuations?
I think it is. So Francis' counterproposal is really, I can show you the rational reconstruction of his proposal, by the way. I worked that out last week. It's really just a weird stateful form of multi-prompt delimited continuations. Yeah, so you hear more about that tomorrow as well. And then there's thread, and that has been in the making for a long time. Really, the name of this. So threads is a bit of a misnomer actually for this proposal, because all it really does is adding instructions for atomic memory access.
It's essentially all the bits of currency except threads.
Yeah, exactly. So you have synchronization instructions, but you don't actually have instructions to create threads. So that is currently assumed to happen sideways, right? So on the web, the way would be web workers. So the thing is, you can now share WebAssembly memory between web workers, and inside WebAssembly that amounts to having multiple threads.
So what happens now is that you said you could share the linear memory.
Yeah, but not across threads.
Well, I think the context you want is you create a new web worker. You can post message to memory between the web workers, and then the browser running in each of the set of web workers is allowed to share access to the same.
Okay, is that currently possible?
Yes.
Okay, then does that mean they just base?
No.
Yeah, you have C11 install semantics.
By currently, you mean before this proposal? It's not possible, right? But this is all already implemented and has been for a long time in browsers actually, and then it was completely stalled by Spectre. So browsers were about to ship this, and then Spectre happened.
Okay.
and so, but yeah, the idea is that you actually have to mark memories that can be shared across the threads as shared. So it's a new kind of memory type. So you have to be very explicit about which memories are shared and which are not. And those you can now post message to another web worker and then shared memory on which you can use these instructions. So really, it's just like the kind of things you would expect here. Instructions.
But once both sides of the web worker have the reference to the memory, then it's a complete memory access.
Right. Yeah. So yeah, I already said that. So we are distinguishing the types of shared memories, but we have no actual instructions for creating. So that will potentially happen at some future point when WebAssembly folks talk about that, they talk about it in terms of calling it like pure Wasm threads, which is a bit of a weird way of naming it, but that doesn't exist. Right, and of course, this introduces natural non-determinism, right? But worse than that, also introduces the whole mess of relaxed memory. And we have had a whole paper. And that is essentially, as Konrad already said, it's like a somewhat stricter version of the C++.
So given that you're being so strong about formal semantics, and given that we know that there's a thin air problem, what is there a contradiction or is there not?
Well, the problem is, this is literally a case of the state of the art in formal semantics across the whole body of research is not good enough to write the precise model we want.
Exactly. So what's now happened to his claim of a formal semantics for that?
We've done the state of the art, and once the state of the art gets better, we'll improve what's in the state. But that's the best we can do.
So, I mean, we have a formal semantics. It may not be exactly what you want, but nobody knows better. So what can we do? And I mean, these are very, in practical terms, it probably doesn't really matter anyway. It's more like really getting the model precise. But
I'm just trying to think, when should it matter which matter? You know, of course the model should be correct, but then of course it can't be. So then how does one think about when does it matter, etc.? I don't know the answer.
Yeah, I don't know how people deal with that problem in general. We can models, right?
Alcohol.
But
Maybe a little bit of alcohol.
with alcohol, you need quite some to swallow that. I saw Sam was making a comment earlier about.
Yes, I don't think exceptions are generative in the sense of ML. They can only be declared at the top level of a module campaign. And then I replied, yes, but a module can be instantiated arbitrarily in the middle of execution.
No, yeah, they're really generative in the same way, except that functors are kind of outside the language a little bit. Okay, more questions about that? Or yeah, this is another thing that's going to be a lot of fun to formalize.
It's going to be a lot of fun for someone else to work out the general solution to the thin air problem, and then I will happily take from them to correct. But I'm not going to work that out myself.
So the way we have formalized it, of course, is we have a reduction semantics as before, small step, and it's now labeled. So we emit like these memory events, and then there's a whole axiomatic layer on top that constrains the valid set of events. Yeah. And since we're already talking about that stuff, so there's ongoing work about extending the SIMD support with non-deterministic or actually implementation-dependent semantics, because of the problem we talked about before, that some of these instructions actually differ across CPUs in a way that makes it hard to have a deterministic semantics without using the performance benefits for using these instructions. So yeah, so these are instructions that have non-deterministic behavior. And they are like marked with specific mnemonics, where like on some CPUs, like some corner cases are doing somewhat slightly different. I forgot all the details because I usually have to close my eyes when I see that, but yeah, rounding, for example, like rounding catch cases. So this is something I really, really strongly dislike for the obvious reasons. I'm still not entirely convinced, to be honest, that this kind of implementation-dependent behavior is necessary. So we had some discussion, I think last time they brought it to the meeting, whether like regular non-determinism wouldn't be enough, right? But they actually want something more. They want certain choices to be consistent across multiple instructions, right? So an implementation can pick from a set of possible semantics, but they have to be consistent across instructions, which in the abstract, okay, makes sense, but it makes it even more horrible to specify because you now have sets of things in terms of the non-determinism or arrays of sets of things, and you have to index them consistently or something. So, and I don't know if that is really important in practice. Personally, I'm not convinced yet. I don't know. Maybe Conrad has another opinion there.
I think it's a big mess, but politically it's inevitable.
Yeah.
So it's almost our job as formalists to just kind of go with the tide, try and do the best we can.
Yeah.
Same with threads, right?
Yeah. So now that we have all these horrible things in there, one thing you might also consider as well, what if I don't want them? Or some of them, or actually I can't afford it, right? So non-determinism is something, in some environments, you simply can't have that. Like I mentioned before, when you're running replicated computation, that's simply not an option. So one thing we have also discussed, and it's still on my plate to actually turn it into a proper write-up for proposal, is subsetting the language. Subsetting the language means that the spec defines certain profiles and intersections of subsets in the Wasm spec. So, because what is going to happen inevitably is that certain users of WebAssembly can only implement a subset of the language. So that's unavoidable, right? So how do we deal with that in the best possible way? You could just let everybody do their random thing, and then we have maximal fragmentation. Or we could try to at least minimize the fragmentation by specifying very properly certain subsets of the language with the properties that are needed. So, for example, a subset that doesn't have GC, because I don't know if you're running on an embedded system, you might not want to support GC or threads or non-determinism in general, right? So we want to put something in the spec that allows us to define these sets. Yeah, the goal is really to minimize fragmentation, although this at first looks like we are now introducing fragmentation. It's actually just trying to address a practical thing that's going to happen. And currently my idea for doing this is that we can basically just mark, so we introduce certain feature flags, just, I don't know, letters or something, and then we can mark reductions in the abstract grammar or mark certain rules in semantics, either typing rules or reduction rules, with a letter, then say that this rule or production is only included in the language if this features. Right? And that way you can basically say, okay, this is an optional rule, and if you don't use that feature, that rule doesn't exist. So you can only use the others. And by that, you can subset the semantics and the syntax. The preferred way is always subsetting the syntax, then everything else follows automatically. But you can also, to achieve determinism, you could also subset the semantics somehow. So certain overlapping rules are removed or something. That's the basic way. And then, of course, some rules could be marked with multiple of these tags, which means they are in the intersection of certain features that exist as well, right? So they're only active when both these features are. Okay. Yeah, and of course, in practice, you want as few as possible of these. Then there's the whole thing about components, which I thought Amal would talk about. But maybe let's skip all of that, because that is not really core WebAssembly anymore. That's really actually a layer on top where we define a component system. So like a new kind of format that allows you to package up WebAssembly modules and instructions for linking them, which essentially was rediscovering the ML module system. So there's a layer of that on top of WebAssembly. And another part of this is really intended to provide like a language neutral composition layer. So part of that is also a new higher level type language that is language neutral but higher level than WebAssembly, and where you can specify how it's lowered into WebAssembly. So this type of language, you have the kind of canonical type algebra with reference variants and all these things. Right. And the idea here is, at least for now, that the whole linking mechanism is really tailored towards shared nothing. Shared nothing concurrency or shared nothing linking. So you have full encapsulation. All information that is passed between components or modules has really to go through this higher level type system, where you have explicit conversion, at least as far as the semantics is concerned. So the engine might optimize that, but anyway. So really, there's no shared memory here. So it's very loose covered. But it's a complex thing, lots of work involved. Amal students doing some of that, respect formal semantics. This is probably still there. But this is also supposed to be the kind of foundation for this other effort that has been going on for a while, which is WebAssembly system interfaces. Which is, the idea here is to create a whole framework of kind of environment agnostic libraries. So if you run WebAssembly on different environments, you have completely different capabilities that you could import, right? So this is trying to abstract away from them, maybe to be able to virtualize some of that on environments that don't have like file system or whatever, have a general framework for that. And the idea is that this is based on system, component, language, and type system. But honestly, I'm not really followed this, so I can't say much. And I think that was it. Yeah. Oh, is that all? No. Yeah, there's lots of stuff. I only included the stuff here that is has ongoing work. Right? There are more proposals there which are kind of like not really active, and there are various ideas out there as well which haven't really turned into proposals. And then there are some smaller proposals which I didn't bother mentioning. This is like the main things that are actively being. I hope I didn't forget. Yeah. So. All right. How scared is everybody?
Once you have GC and continuations, you'll have lists with parentheses.
Yeah, indeed, but you're not untyped.
Yeah.
At the same time, your type system is not very powerful. So. Yes.
So as a reaction to try to get myself less scared, my questions, how simple can you get those subsets? So in particular, various IoT things. Is there a sense that actually one can go very simple with certain?
I mean, basically what's in WebAssembly 1.0 would be an obvious minimal subset.
Yeah, so 1.0 is fine. And then is the demand to put all the bells and whistles on? Or is for some application, the demand is to just put this little thing on here?
Well, I mean, there is a tension between having very targeted subsets for very specific applications, right? That just want this one extra thing or something, and minimizing the number of these subsets that you want to introduce. So I don't.
Yeah, I'm thinking more sweet spotty for IoT rather than very specific applications.
So I mean, one one obvious starting point is the proposal suite, right? You could make every proposal like an optional part of the language. So basically every slide I had could be one thing you can take out. That would be a granularity. I think that would be too small a granularity. But that would probably address the kind of thing I think you're asking. But yeah, you have to somewhat find the...
Yeah, so for example, 1.0 sure, obvious. Then actually 2.0 is all of that necessary, or can we get the vectors out?
For example, so I've been actually lobbying for, SIMD should be optional. There are people who disagree with that. I think it's very important because it's such a large thing, right?
Yeah.
Yeah, I agree. So that is just for the economics of implementation to make that optional in environments where performance isn't actually that relevant. So you don't really have any particular benefit from SIMD in the first place, right? Yeah, because it's really just an optimization.
Ben is making the point I wanted to make in the chat. SIMD will be optional just by implementation reality. We're already seeing engines refusing to implement not important ones, but small ones like watching kind of adjacent things.
Yeah.
So if our profiles don't give people the granularity of options they want, they're still just going to reject certain instructions and refuse them.
Yeah.
And that has been my argument as well, right? But I have had that argument with some people who disagreed and said, we should just force engine to implement that. Right?
Yeah. And then another one's what sort of concurrency is needed. So the web workery message passing stuff is different from the hitting at the shared memory.
Well, that's kind of outside the language, right? So, but you certainly want to have a profile where all these atomic instructions don't exist because they don't make sense if you don't have threads. Right?
Yeah.
Something like that. So the ones I'm thinking currently of is like GC would be one, SIMD would be one, threads would be one, or actually the negation of these units. And then determinism would be one. So those are the four kind of ones that I think as obvious candidates. But I don't know, we didn't really have a discussion yet what exactly we need. And of course, you can always extend, you can also always introduce more subsets, right? But yeah, if it's creating too much fragmentation, you can find the sweet spot. But this is probably more political.
I'm pragmatically, so Wasm time for a while fuzzed against WASMI, which is like this little definition interpreter. And they're kind of in trouble because WASMI is refusing to implement SIM, so they have had fuzz their SIM implementation.
Yeah, so I just didn't have the time to do it, and I think it wouldn't have worked time-wise anyway. I thought we should not have merged SIMD without profiles. Without profiles.
Yeah, I think positively that was the big.
But all the more, I think, once this first line of GC is out the way, I really want to put that up again. I just fear that's going to be a lot of tedious discussions, which I really not looking forward to. So technically, I don't see much of an issue there at all. It's about people are willing to accept it or not. Well, extrapolating from recent discussions and notes of discussion, that's not.
I mean, in the very worst case, when we don't have profiles at all, it's still the case that if producers produce WASM that doesn't really run on the engines people want them to, they're going to play. So everything will kind of work itself out together.
Yeah, you would hope so.
That's what people say when they say C is portable.
That's also what people thought when they put defaults into the JavaScript standard. And it's still not sorted out.
Well, actually, I'd say there's a good analogy there, because the reason tables started in JavaScript was because science refused to implement.
Yeah.
So,
yeah, but
the engines.
Right, but technically it's still in the standard, right? So
I thought tables were ripped out of JavaScript.
were they? Maybe I just missed that.
There was a this is one of the reasons we have the modern JavaScript process, because it was such a drama, so great to understand that.
Yeah, sure, but I hadn't seen that they were actually
I thought they were right.
because they would never, at least I remember this disastrous meeting. And there was neither consensus to implement them nor consensus to take them out. So it was like a complete deadlock. So
Shall we thank Andreas again? And I didn't mind going over this discussion because it was better to hear what Andreas had to say, but why